Okay, so this is the third period review video. The title tells you which problems we're doing, but there we go. We'll do the third period set of problems. And when we get through those, I'll happily backtrack and do any others that we passed along the way that you had questions about. So, again, only the odds, and we're going to do a third of the odds right now. So, number one, fishhook. 5 to the something equals 0. What do you think? Undefined. That doesn't work. So, no solution. There's no way to get that answer. Okay, so just remember that no solution is an acceptable, viable, possible answer tomorrow and Thursday. So don't panic if that happens. Realize, that it can happen, so okay. I mean, it's not going to happen a ton, but it's okay if it happens. Skip to number 7. This is the problem with just jumping around. 3 to some power equals -9. That also doesn't work. There's no way to get to a negative as an answer. Right? A negative exponent would flip it over. Fraction exponent would take a root, but there's no way to make the answer negative, so that won't work. Giant? Base?
Yeah, but like if you had a base and then for example, -3 and then -27.
Sure. I know what you're saying. If the base is -3 and the answer is like that you could fishhook, and you would think a 3 would go there. Here's the deal with that. You're not allowed to have a negative base.
So
you'll never have a negative base. If there's a negative base, the answer is you can't do that. So even though I see what you're saying, the fishhook would suggest that answer is 3. But you can't have a negative base.
So if there's a negative anywhere in there, like we automatically know it's in this solution.
Is there a negative? Yeah, that's true. If the negative base or a negative argument, that won't work. Yeah. Be careful, you can still have a negative answer, right? Number 13. Log base root 3 of 27 equals 5x. That's weird looking. Any idea on what we should do with that thing? Make it a 1/2 power. I like that. I would do something before I did that. Let's fishhook this guy. So root 3 to the 5x equals 27. Okay, and then I this is a no calculator, so maybe I could make the bases be the same. So I could replace root 3 with 3 to the 1/2. And if I hadn't already noticed that 27 has a 3 kind of hidden in there, I could hopefully catch it now, that I could replace 27 with 3 cubed. Power to a power we multiply. So 5x over 2 equals 3. So x equals 6/5. Giant?
Could you also just simplify the log itself without moving what's the 27?
Forget about the 5x, just figure out what log root 3 of 27 is? You could have done that. That's a good way to go, because that would be 6. Yeah. That's arguably a better way. I mean, you get the same thing, but yeah, if you can figure that out that that's 6, that does make that problem easier. For sure. Good question. Let's look at 19. Oh, 19 looks pretty straightforward. Why don't I take a break and 5 cubed equals 2x minus 5. And here's where, how many steps do you want to show? 125 equals 2x minus 5. So 2x equals 130. So x equals 65. That's a pretty straightforward one there. Let's jump down to 25. Let's see, I guess I should read the directions. Expand. Expand. Okay, so anything multiplied is positive, anything subtracted is negative, but I'm not done yet, right? I can't just stop there, because what else can I do? The exponent, so I can definitely move the 3 out to the front. What about that 2? It doesn't go to the 5, so I can't put it out front yet, but I could split up the 5 in the x squared and then put it out front. Like that. So the 2 can go out front, but only out front of the x, because only the x is being squared. 5's not being squared. Let's see, 31. 31 is a condensed problem. Oh, this is one of those, like, how many steps do you want to show? I'm feeling confident. All of those coefficients are going to go up as exponents, so that's an easy. So 4 to the 4th, 3 squared in the bottom because it was subtracted. Now I need to be careful. 16 to the 1/2, that's 4. Where's that 4 going to go? In the top or the bottom? I'm going to put that. It's going to go in the bottom because we're subtracting. So 4 to the 1st in the bottom. 81 to the 1/2 is 9. But where's the 9 going to go? Top or bottom? Why top?
It's positive.
Right, because it's positive. The negative times the negative makes this positive, so the 9 will go in the top. Which works out pretty well for us, because 3 squared and 9 will cancel. 4 to the 4th over 4 is 4 cubed. And we get a reasonable answer. After, I don't know, maybe not being so sure with 4 to the 4th times 9 in the numerator. Let me put 32 on this video because we haven't done a graph in a while, and there's only one on the review, so it's not an odd, but we need to do that. Now, it's been a while since we did a graph, so let's just maybe start from scratch. If you got a graph you don't know what's going on, what do? Plug in points, make a table of values. What's the minus 3 doing, though? I do know that much. Down 3. So that means I can do a table and not have to worry about the minus 3. I can just do a table of 2 to the x. Now, we're not starting completely from scratch because it would be helpful if you remembered 3 good values of x to plug in. -1, 0, and 1. So 2 to the -1 is 1/2. 2 to the 0 is 1. And 2 to the 1st is 2. And I'm not doing the subtract 3 because I've already handled the down 3. So -1/2, or -1, 1/2, 0, 1, 1, 2. That's not much. What would the next point be if I wanted to make sure I'm headed the right direction here? 2, 4. Yeah. And now I've got the hang of things. So 3, 8 would be on the graph as well if we really want to. Another one. Going the other way, 1/2, this is where it starts getting close to 0. 1/4, 1/8, 1/16. I'm not graphing any of those. I'm just sort of mentally reminding myself that I'm getting closer and closer to that asymptote. Oh, speaking of asymptote, Looks like it's right there. Y equals -3. So that down 3 shifted my asymptote down 3. Let's see, I don't know if we did domain and range on these the first time through, but what's the domain of that function? Yeah, all real numbers, or -infinity to infinity. Goes forever left and forever right. What about the range? -3 to infinity. Don't include -3 because it's an asymptote. We're getting closer and closer to -3, but we don't ever get there. So we start at -3 and on up to infinity. $33 I'm going to let you do, but I'll remind us of a couple things here. What's that +5 do in there? Left 5. And I don't really like doing log problems. I'd rather do exponent problems. So I'm going to do a table of values with a slightly different equation. Remember, this is kind of weird because which column, which coordinate are we plugging things into? X's or Y's? Y's, because this is backwards. So we'll skip that. Let you finish that one. Let's jump to number 37. Simplify each expression. Oh, that should be easy, I think. What's e to the 4th over e? E cubed. Again, that's part of the reason why the no calculator part has way more questions than the with calculator part, because some of them are this kind of thing that should go really quick. All right, 43. We've changed to with calculator now. 3 decimal places. What do you want to do first on 43? Subtract the 10. And then divide by 5. Getting ambitious here. 20 minus 10 is 10. Divide by 5 is 2. 2 steps at once. We can handle that. What next? Natural log both sides to get the exponent to not be an exponent anymore. So 0.1x natural log 3 equals natural log 2. So I'm just going to divide both sides by 0.1 natural log 3. And that'll get my x by itself. Grab a calculator, make sure you can type this in the right way, because this is a good one to mess up. I'll intentionally mess it up because it's an easy one to mess up. Natural log 2 divided by 0.1 natural log 3. But that is not the right answer. Do you know why that's not right, or what I have to do to make it right? Parentheses. Like, your calculator knows order of operations, so it divides by 0.1 and then multiplies by natural log of 0.3, but you want it to divide by all of that, so 0.1 natural log of 3. I think you'll have plenty of time on test day, both test days. So that would be a good one to plug it back in if you weren't sure. This also might have been one where the fraction bar might have helped us make sure things are in the right spot. Yeah, there we go. So again, just be super careful with parentheses, or use the fraction bar to make sure you know who's in the top and who's in the bottom.
How do you do the fraction bar again?
The fraction bar is alpha y equals, or alpha f1. And that first option is n over d. That stands for numerator over denominator. and then you're good from there. And you could even put fractions and fractions. So if somehow you need the natural log of 15 divided by 87, whoops, I don't need, like you can put fraction bars in fraction bars. I don't know if there's some limit to that, like fractions and fractions and fractions. Apparently there's not a limit, or I haven't reached it yet. So we'll never have anything that bad, but fractions and fractions, it can handle it. All right, skip down to 49. 49 looks like the same type setup as 43, so why don't you try 49? Cautions about calculator usage would apply here. Parentheses or fraction bars or both, or just be careful. Oops, 1497, so that's really 6.150. Reminder, easy to check, and I think you'll have time. Again, you got the answer right there in your calculator, so I'm going to do this one. 20 minus 6 times 4 to the 0.5 times answer. All of that is supposed to be negative 406. Fingers crossed, I know I got it right. Again, I think you'll have plenty of time on the calculator day to check answers. You don't have to, but man, it's so quick, and you'll know that you got the answer right. You'll feel good about turning it in, or if you need to go back and fix things. All right, 55. That looks different, but I would argue it's easier, I think. What would you do first on 55? Natural log both sides. Because that will get that x plus 3 down front. Natural log of e is 1. So all I have to do is subtract 3. That's an easy one. Natural log of 8 minus 3 is negative 0.921. And I didn't print the key, so it's my first time through some of these. So I'm not 100% convinced that's right. So e to the answer plus 3 is supposed to be 8, and it is. Again, well worth your time, I think, to check them and make sure they're right. That's why I'm checking them, because I don't have the key with me. 61 is a weird looking problem. Thoughts on what you'd do first on 61? Jacob? What's that? I don't know yet. I can't tell by looking if that's undefined or not. So, sort of ignore I got two natural logs here. Let me color code them so I can talk about them. Let's ignore the pink one for now. Let's worry about fixing or undoing the yellow one. So if I had natural log of something equals 0, what would you normally do as a first step? Fishhook it. So let's fishhook that thing. So there's a base of e, the invisible e base there. So this feels weird, but e to the 0 equals natural log of x equals the pink natural log of x. Okay, what's e to the 0? 1. And then we can fishhook again, or maybe you know it well enough, you just look at it and you know what x needs to be. But if not, you fishhook it. e to the 1 equals x, so x is just e. So kind of a weird problem, but one that you could be able to figure out. Back page, 2 more. Why don't you try? Yeah, it's perfect. We're going to omit 73 because you don't need to know how to do that one. Why don't you try 67? So x equals 1/4. All right, omit 73 because that involves a factoring that we're not going to mess with. A factoring that we would have to know is number 66, so there's a little hint there. That's not an odd problem, but I would recommend 66. How about that? Okay, so if you're watching the video and you want one of the other problems, there's the key. You can press pause and figure out which video you need to go watch.